Hi everyone, it's Miss Berry. We are going to go over section 10.2 in this video, so I'll mute my camera and share my screen and we'll get started. All right, so we're looking at section 10.2, which is called hypothesis testing for a population mean when sigma is known. All right, so a couple things to just take note of here. All right, so I would say that this is the easiest type of hypothesis test to conduct. So again, we're working with a mean here. So we're testing some kind of, oops, let me go back, sorry. We're testing some kind of assumption about a mean. And in this scenario, we know the population standard deviation. So that's sigma. So that's the population standard deviation. And we've talked about this scenario before and that it's really an unrealistic scenario. Although there are some situations where the population standard deviation is a value that is known based on previous studies. Right, so while this is somewhat unrealistic, there are scenarios where you would use this type of hypothesis test. All right, so just to remind you, these are the 4 steps that sort of outline our hypothesis test. We begin by stating our null and alternative hypotheses. That's HO and HA. Then we figure out what type of test are we going to use. We state the level of significance alpha. Again, that's given to us in these problems, but if you were doing this in real life, you would look at previous studies and see if there's any sort of traditional or historically used alpha levels for your field of study. Step 3 is the step that would take the longest in real life. This is where you gather the data and calculate your sample statistics. You would generate, frequency distributions and graphs and tables. And then after you reviewed your data and you observed patterns and trends, you would draw your conclusion and then interpret your decision. All right, so let's get started. Here's our first test. It says a manufacturer must test that his bolts are 4 centimeters long when they come off the assembly line. He must recalibrate his machines if the bolts are too long or too short. After sampling 81 randomly selected bolts off the assembly line, he calculates the sample mean to be 3.97 centimeters. He knows that the population standard deviation is 0.14 centimeters. Assuming a level of significance of 0.01, is there sufficient evidence that the manufacturer needs to recalibrate the machines? All right, so we're just going to follow that general outline. So we start with our HO and our HA. Again, we know that we are looking at the mean. We saw the word mean in there. All right, so we'll go ahead and put mu on each line. That's our population mean. We know that our null hypothesis always gets the equal to. And if you read through this problem, can you determine what is the value that is currently believed to be true about these bolts? What is their average length? Yeah, they're supposed to be 4 centimeters long. All right, so that's the value that's currently believed to be true, is that these these bolts are approximately 4 centimeters long when they come off the assembly line. Now it says that he's going to recalibrate the machine if the bolts are too long or too short. So he's looking on both ends of the spectrum. So we're not leaning towards a less than or towards a greater than. We're looking at a not equal to situation here. So if they're too long or if they're too short, we have to recalibrate. Now, that is step 1, is to write down your null and alternative hypotheses. Then we figure out what type of test are we going to use. And we talked about this in the last video. And if you remember, if you're doing a test for a mean, so we're doing a test for a mean, sigma is known, then we do what's called a z-test. If sigma is unknown, then you do a t-test. All right, so speaking of sigma, We'll go ahead and write that down. I'm sure we'll need to use that in just a minute. All right, but we're also supposed to be stating the level of significance, which is alpha. We were told that that was 0.01. All right, so remember, alpha is like the probability of making a mistake. So this is a very low chance of making a mistake. All right, so 0.01. All right, so let's grab our calculator. And I think I told y'all this in the last video, but how we get to these hypothesis tests on our calculator is we hit the stat button. Then we go over here to test. And it's the first option. A z-test is the first option. Then you see t-test. And then we'll also do a 1 proportion z-test in section 10.4, I think. All right, so right now we're going to do a z-test because we know the population standard deviation. So hit enter. This is going to kind of look similar to the confidence interval. So if you had typed in the data manually, you would go in and hit enter on data, and you would say, okay, I've typed this into a list. We did not have to type in the data, so we're just going to keep it on stats. And then we've got a bunch of stuff here that we have to work with. You see mu 0, that's the null hypothesis, so we're going to put 4 in there. That's our value that's currently believed to be true. What did we say our population standard deviation was? 0.14. Right, 0.14. All right, our sample mean, I didn't even highlight that, I don't think. Let's see, our sample mean was 3.97. All right, 3.97, so pretty close to 4 centimeters. And what was our sample size? Our sample size, okay, he sampled 81 randomly selected bolts. All right, so sample size is 81. All right, so a bunch of stuff you got to type in. And I definitely would say that the order seems totally random in the order that you type this stuff in. So like having sigma go before the sample mean. Yeah, so there's no good way to remember like what you're typing in. You just have to read it. Be careful. All right, so then you're going to go in here where it says mu. So right there, that's, there we go. There's mu. And you're just going to select what your alternative hypothesis was. Ours was not equal to. And then we're going to go down here and hit calculate. Now, if you were doing the rejection region method, you would do the draw option, but we're using our p-value method. So we're going to go to calculate and hit enter. And there's our values. You can see it gives you a critical value, gives you a p-value, gives you your sample mean and your sample size. All right, so we are just grabbing the p-value off of here. So 0.05. I always do 2 or 3 decimal places for my p-value. So we'll do 0.05. All right, p is 0.05. All right, so now remember the rule. This is our last step of the hypothesis test where we draw a conclusion and then interpret our decision. All right, so when we're drawing our conclusion, the general rule of thumb is if P is low, reject HO. Okay. All right, so now you're just going to, and we said what this means is that if P is less than alpha, you reject HO. If P is not less than alpha, so if it's greater than alpha or if it's equal to alpha, then you fail to reject HO. Okay, so let's compare our p-value and our alpha value. Is p less than alpha? So remember, p is 0.05, alpha is 0.01. Sometimes people struggle with these. If you haven't compared decimals in a while, you might be a little rusty. I always just convert these to percentages in my head and think about them that way. This would be 5%, this would be 1%. Yeah, that's definitely not less. Right, so that p-value is definitely not less than alpha. All right, so we're going to fail to reject the null hypothesis. All right, so if you remember that little template sentence, I'm just kind of winging it. I don't have it sitting in front of me, but it was something like this. We do not have sufficient evidence. We do not have sufficient evidence at the, and then we had our first blank, level of significance. All right, so our blank we're going to fill in with 0.01. That was our alpha level. Okay. So we do not have sufficient evidence at the 0.01 level of significance to say, switch, there we go, to suggest or to say that the bolts, we're just rephrasing our alternative hypothesis. So to suggest that the average length of the bolts is not equal to 4 centimeters. That was the second blank. It was just a rephrasing of the alternative hypothesis. All right, so let's talk about what this means. I'm gonna try not to bore you too much, but I do want to, talk about how we would interpret this. So this is our interpretation sentence. But what does this interpretation sentence mean? It just means that based on the evidence that we have at our disposal, so the 81 randomly selected bolts, their sample mean, and the population standard deviation. So based on all of that information, we do not have enough evidence that would be enough to disprove this null hypothesis. So we don't have enough to say that it's not equal to 4 centimeters. All right, so as of right now, we tried to challenge this assumption that the mean was equal to 4 centimeters, but we didn't have enough evidence to disprove that. So we can just assume that the mean is truly 4 centimeters. All right, here's another one. Again, all very similar scenarios, just with different numbers. This one says, the director of research and development is testing a new drug. She wants to know if there's evidence at the 0.05 level that the drug stays in the system for more than 397 minutes. In a sample of 62 patients, the mean time the drug stayed in the system was 402 minutes. Assume that the population standard deviation is 18. Conduct the hypothesis test. All right, so let's go through our 4 steps. We start with writing down HO and HA, null hypothesis and alternative hypothesis. All right, so again, we're seeing the word mean, so we'll go ahead and put mu in there. Null hypothesis always gets the equal to. All right, so what's the value that's currently believed to be true? How long do we think the drug stays in the patient's system? That would be the 397 minutes, right? So as of right now, this is what we think, or this is what is believed to be true. But this director of research and development, she believes that it actually stays in the system for more than, so greater than 397 minutes. All right, so we've got our null and alternative hypothesis stated. Now we'll go in here and write the test type. Right, we do know the population standard deviation, so we're doing one for a mean. Sigma is known, so we're going to do a z-test. All right, so the population standard deviation was known to be 18 minutes, so we'll go ahead and just note that here. And then we also needed our X bar value. We saw that when we did the last problem. So X bar was 402. And then what was our sample size? It was 62. All right. So and we got to state the level of significance, sorry. Alpha is 0.05 level. That's what they said, 0.05. All right. Let's grab our calculator. The hypothesis tests are very straightforward to do on the calculator. So again, you just go to stat, go over to test, select the correct test, so z-test. Then you just type in the information, 397, that's the value that's currently believed to be true. 18, I believe, was our population standard deviation. X bar was, what was it, 402? Yep, 402. And then sample size was 62. All right, so 402, and then sample size is 62. Now, this time the researcher said she believed that the medication stayed in the patient system for greater than 397 minutes. So she thought it was more than 397. So we'll switch that alternative hypothesis to greater than, and then go down to calculate and hit enter. And there's our p-value, 0.01. Right, 0.01. All right, so p was 0.01. All right, now we're ready to draw our conclusion. Remember, we ask ourselves the question, is P less than alpha? If P is low, we're going to reject HO. So is P less than alpha? It surely is. It's 0.01 and 0.05. So yeah, that's like 1%. This is like 5%. Yeah, 1% is definitely less than 5%. All right, so we're going to write our conclusion statement. We would say something like, we do have sufficient evidence. We do have sufficient evidence at the 0.05 level of significance to conclude or to suggest or to determine. I'm going to say to suggest, since that's what I did on the last page, I think. So we do have sufficient evidence at the 0.05 level of significance to suggest that, and let's see how she said it, that the drug stays in the system for more than 397 minutes. To suggest that the new drug stays in the patient's system for more than 397 minutes. All right, so in this scenario, we were able to reject HO. I forgot to write that. On the last one, we had to fail to reject HO. This time we're rejecting HO. And what does that mean to reject HO? That means that we're concluding that we in fact did have enough evidence to disprove our null hypothesis, and so we can now assume our alternative hypothesis is true, which is that the mean time that the drug stays in the patient system is greater than 397 minutes. Right, I want to go back to the last page and just make, oh, okay, I did. I wrote down fail to reject HO. Okay, just want to make sure. All right, so now you've seen an example of each. I want you to take a second and pause the video. I really think this would be helpful if you did it. Pause the video, try this problem on your own, and then make sure that you get the correct answer. All right, so I'm going to work the problem. I think I'm just going to work it kind of quietly. That way, if you do want to just leave it unpaused, you can. All right, I'll read the problem to you. It says, the knot.com states that the average cost of a wedding is $29,605. Suppose that your friend is hoping that the average is less than what's reported. To see if their hope is correct, she surveys 59 recently married couples and finds the average cost of weddings in the sample was $28,420. Assuming that the population standard deviation is $3,653, is there sufficient evidence to support your friend's hope at the 0.02 level of significance? All right, so I'm just going to start working the problem. If you want to pause the video or just work alongside me. Okay, I'm grabbing my calculator. Put that in the wrong spot. Let me fix that. Oh, very small p-value, 0.01. All right, so hopefully you have, if you're not finished, you'll need to pause the video, keep working. But hopefully you have gotten to the same place that I'm at and you've seen that we're rejecting HO. And our conclusion statement is going to look something like this, or our interpretations. We're going to say, we do have sufficient evidence at the 0.02 level of significance to suggest that, let's see how we want to word this, the average cost of a wedding, the average cost of a wedding is, and then again, we're restating the alternative hypothesis. So we'll say is less than $, $29,605. Okay, cool. All right, and our last problem, a recent survey reported that the small businesses spend, whoa, okay, I can do this. A recent survey reported that small businesses spend 23 hours a week marketing their business. A local chamber of commerce claims that small businesses in their area are not growing because they're spending less than 23 hours a week on their marketing. The chamber conducts a study of 96 small businesses within their state and finds that the average amount of time spent on marketing is 22.2 hours per week. Assuming a population standard deviation of 4.8 hours, is there sufficient evidence to support the Chamber of Commerce's claim at the 0.10 level of significance? All right, so I'm going to set up my null and alternative hypotheses. Let's see, I'm looking for a word. I'm looking for the word mean. Oh yeah, there we go, average. All right, so I see the word average. I know that I'm working with the average or the mean. So put mu on both of them. I know that the null hypothesis gets the equal to. The value that's currently believed to be true is 23 hours a week. So they're saying that they believe that the average amount of time that they should spend on marketing is 23 hours a week. The local chamber of commerce believes that people in their area are spending less than 23 hours a week. So that's our alternative hypothesis. All right, and then our test type, we do know the population standard deviation, so that's definitely going to be a z-test. Level of significance was 0.10. And again, remember, this is like the probability of making a mistake, so that's pretty high alpha level. So that's saying that 10% of the time you're okay with making a mistake. Or I should say that differently. I should say they're okay with being wrong 10% of the time. All right, and then I'm just going to write down the rest of my sample statistics. X bar they found was 22.2. Sample size, they surveyed 96 small businesses. And then sigma, my population standard deviation, they said was 4.8. All right, I think that's everything I need. So let me grab my calculator. Okay. Clear this out. Stat test, z-test. All right. My value that's currently believed to be true is 23 hours. Population standard deviation is 4.8. X bar, the sample mean was 22.2. Sample size was 96. And same alternative hypothesis. So still looking at having less than 23 hours a week for the alternative. So I'm going to go down to calculate. There's my p-value, 0.05, 0.05. All right, so let me write that down. All right, so p-value, 0.05. All right, so now we're going to go on and draw our conclusion. So remember how we do that. We ask ourselves the question, is P less than alpha? Because if P is low, if it's lower than alpha, we're going to reject HO. All right, so 0.05. Would you agree that 0.05 is less than 0.10? Absolutely, right? That's like 5%. This is like 10%. So yes. All right, so we're going to reject HO. And let's write our interpretation. We would say something like, we do have sufficient evidence to suggest, or excuse me, sufficient evidence at the 0.10 level of significance to suggest, got ahead of myself there for a second. So we do have sufficient evidence at the 0.10 level of significance to suggest that, let's see how we want to word this, businesses are spending less than 23 hours a week on marketing. So we'll say to suggest that businesses in this area are spending less than 23 hours per week on marketing. All right, so how could you use this information? Why is it important? Then this Chamber of Commerce could go back to these small businesses and say, hey, we did this hypothesis test, we ran this the statistical analysis, and this test determined that you are in fact spending less than average, less than the average amount of time on marketing. So perhaps if you increase the amount of time that you spend on marketing, your small business may be more successful. Okay, so I'm going to switch back over, stop sharing my screen. All right, there we go. And here I am. Hi. Thank you guys so much for watching this video. And if you have any questions, I hope you'll let me know. And I'll see you guys in the next one.